Any homework question? Any question from homework? No. So this is you. Let's see, what do I have for exit ticket? Let me close the other class. Any question here on exit ticket? So this is week number 6. I'm looking for the week number 4 and 5, okay? We have had a few questions here that's asking how something can be either an element or a subset of a power set. That's really true, right? So Thomas asking, I have no idea how to start with this direct or indirect proof. So as I said, that's really challenging problem, right? So we have learned direct proof, indirect proof, proof by contrapositive, proof by contradiction, and then we have induction. Induction is clear where to use it, right? So, but for direct proof and indirect proof, always we start with the direct proof and try to get it. So if you start with the P, end up with the Q, you don't need to make it indirect proof. But something like just rational and irrational is clear. Being irrational has no definition. So then I have to make it indirect, or I have to make it contrapositive, or I have to make the negation. So for inequality is also the same. So for most of the cases, not P is much easier than showing. So I can say direct or indirect, whichever is really better or shorter. If direct proof works, so why we want to make it indirect? So then I have to start with the direct proof and make sure it doesn't work. So then I go to the indirect proof. For proof by contrapositive and contradiction, they are really different, okay? Proof by contrapositive, we are trying to prove something, but for contradiction, proof by contradiction, we actually most likely, I'll say, if you want to disprove something, proof by contradiction is, or bringing examples works better, okay? So let's think about it. What is the main difference between proof by contradiction? Just write it down, what we are trying to do. So let's see, when you have P then Q, if you want to say proof by contrapositive, you go by this way. So this is proving by contrapositive. If you are having P then Q, you consider that P is true and not Q is true, and you make something false. So you try to say, if I shouldn't use this notation, so you, for proof by contradiction, for proof by contradiction, you consider P is true and negation of Q is true. So then you try to show that's contradiction. So then Q is true. The main question was, where do I decide which one to choose for proving, right? That was the question. How do you decide which way is better for proving? That's a really great question. Do I have any criteria for any of these?
I mean, if you told us, like, proof by contradiction, then I could do that. But if I have to look at problems and decide that proof by contradiction, false or incorrect,
I will say proof by contradiction 99% of the time is quicker, easier process. If you starting with the not Q, it's really quick to get to the contradiction comparing to what's the other one is, because the other one is really like a direct proof. So the other one is really like a direct proof because you start from here and you try to get to this one. It's like a direct proof. Proof by contradiction typically is faster. And unfortunately, most of the time, it's possible to do both. I mean, contrapositive works, contradiction also works. For most of cases we have in this course, either one works, but I will say contradiction is faster to get the solution or to prove. Have you had any case that you tried one of these, like contrapositive and contradiction, but one of them doesn't work? Have you tried any of these that one of them doesn't work? You choose whichever is either asking you or whichever is faster for you to do, right? I don't have any example on my mind that I can say, okay, for one of them, contrapositive works, for the other one, contradiction works. I will say contradiction is really quicker, but it doesn't mean it doesn't work with the contrapositive. So then I don't have answer for that. I will say works, both of them works, unless the question exactly asks me whichever method to use, okay? Well, that's a really good question. I have to find out really one example that one of the proof works, but the other doesn't work. Okay, so this is a good one. I like it. You can try it. I'm okay with that one. So wording with the direct and indirect proof now.
Yeah.
So we're starting P ending with a Q, or we're starting with not Q ending to the not P.
Yeah, no, I understand it now. It was just kind of, I guess, wording of the actual statement, logical statement to the wording of other things.
Did I miss any other?
I guess identifying what's like the P and what's the Q.
If it's given as if then a statement, it's clear, right? Where is P? But if not, yes, you're right. I thought you raised your hand. Anything else here that I missed to answer? Okay. Only week number 5 is still I'm waiting for you guys, right? Only Greg has something. Let's see. Does he have any question? Okay. Not really question, right? Am I right, Greg? There's not really a question here.
No, it was just more maybe reviewing what we did.
Okay. Thank you. So Alex, Griffin, and Bryce Samer, right? We need your comments too, okay? Or anyone from your group. So this is it. Finally, I could sit down and try all of your, group work activities. If you now check, because it was really disaster, students still adding the class and I couldn't really set up my just people assigned for each group work. Now I have them all by the end of the semester. If you look at each of these one, you can figure out which one is assigned to which. If you want to go ahead and do it earlier, you can just find out everything is in the discussion board, not the voice thread anymore, because we have had technical problem last time. And then it's all assigned to the people, and then the announcement, everything set up finally. But still, I have 2 students throughout the course. So if you get the turn for those students, you have to remember, you have to remind me to just remove those people and just give another person to submit this work, okay? I have nothing here. Anyone wants to add, please?
We had a person that dropped in the course in our room. I don't know if that was addressed yet or not.
What was the name?
Nathan Boo,
Oh,
I believe.
I don't have Nathan at all. I didn't know. So I had someone else. So Nathan, which group?
For group number 4.
Is it officially dropped?
Yeah, I believe so. That's what he was telling us in the group chat we had.
Officially dropped.
I'm pretty sure it did.
I'm going to check like this.
Unless he didn't drop himself.
Which group was it?
Number 4. Yeah, it looks like you might have not. Yeah, it doesn't look
No,
like he
it's
dropped
not
himself.
officially. No. So he's not doing the job, right?
Yeah, he's not.
This is not working. Why? It's not working. Okay, if somebody is doing like that, so it's just getting the credit for not doing anything, you have to let me know, okay? So Hamid is something different, okay? Hamid was which group? Group 6. Hamid is different. Officially, he was qualified to teach the course, but I don't know why he was here. So that's why I said he's fine to just be individual. Hamid is different, but everything else, I mean, everyone else must do the job, okay? And if not, like this one, I have to remove, then he'll get 0. Anything else? Anything else? Okay. So we are moving to what is functions for, fortunately, most of us know what's the function, right? We've seen the functions and we know what's the functions. Let me bring my examples here. So when we have a function, so first of all, we have to have 2 sets. So one of them is domain, the other one is a codomain, right? So you start with the domain and you end up with another set, which we call it codomain. So function is a rule that for every single element, so for every single element of the A, you should have one unique element of the B. So there is 2 criteria to here to call it well-defined function. So first of all, whichever element is sitting to the A must have one image on the B, and then it has to be unique image. You have to have unique image on the right side, okay? So we have 2 expressions. One of them is called domain. The other one is called codomain. So A is your domain, your inputs. B is your codomain. And for the way that we've seen it in algebra classes, we call it range. Is the range the same as codomain? No. Which one is bigger? Range is subset of codomain. Okay, so you might have something which is sitting in your codomain. You might have something which is sitting in your codomain, but it's not necessarily image of any x's. It's not necessarily taken by any of the x's. Okay, so then your range is subset of codomain. So when you have a function, as I said, this is another expression, is called image of your x's. So image of your x's on the function of f. So like saying, if you're having f of 2 equals 3, 3 calls image of 2. So 3 calls image of 2. You can just say under f, under function f. Make sense? Yes. So the way that we define the functions over here is discrete, right? So this is the discrete math, sorry, and it's going to be all point by point. So what is the difference? So when I was sitting in my calculus classes, this is the way that I'm looking to the functions. This is the way that I'm looking to the functions. So they are continuous, okay? But here in this course, we are looking for points as a function. Okay, we don't have the whole continuous graph. Okay, so that's how it works. But does it have any different for definition? No, the one-to-one onto function, everything is going to be similar to what we've seen before. So this is one function. So your domain or inputs are ABC, your outputs or your codomains are 1, 3, 5, 9. So you have different ways of showing or defining the function. One of them is the rule. So this is saying f at A is 1, f at B is 5, and f at C is 9. So that's one way to define what we call a function by rule. Another way to define is making a table. So that is just really what we call it in algebra classes, T table, right? So X, Y, X, Y. That's exactly similar to your T tables. So you have X in your one row and then f of X in another row. So does it matter if I write it like this? No, it's fine. So you can write it A, B, C, 1, 5, 9. So that's same thing that we've seen. So you can summarize your function in a table, or you can just show it by graph. So that is one way, one other way to show your function by graph. Another way that we've seen it actually again in algebra classes was ordered pairs. You can just say A assigned to the 1, B assigned to the 5, C assigned to the 9. So that's also one other way of showing any function, by showing the ordered pairs, tables, graph, or just giving the rules, okay? What do we call a function, or basically what do we call a well-defined function? So where we call a function to be well-defined, it says there should be 2 rules. First of all, whichever elements that is taken in the domain must have for sure an image. So first of all, whichever element that's sitting in your domain should have one image. So if in this example, you try like A, and then B, and then C, and then D, then 1, 3, 5, and 9. So you're having this, and then this, and that was the C to the 9. So then your D, which is one element, so your D, which is one element of your domain, has no image. So that is not well-defined. So this is not well-defined function. Why? Because number 1, if I call this one number 1, fails. Number 1 fails, okay? Is it okay? Question here? The other criteria over here, it says you should have unique image. So if you have image, it can't be repeated. So like, can I have A corresponding to the 3? Does it make a function? So I'm going to write the ordered pairs again, because you've seen this one. This is a new example, okay? So you've seen this one in your calculus, maybe algebra classes, I don't know where. This is not a function because
The statement here, and
the output is just not unique. Your output for A is not unique, okay? So if I just remind you one thing that you've seen in your calculus classes for functions, that was one example, which is a function, that was one example, which is not a function. You remember, right? This is a function because, again, that I shouldn't bring any example from calculus because calculus, everything is continuous here, everything is point by point, is discrete, okay? So it's different than calculus. But if you remember, you have had a test in algebra classes to say something is a function. What was that test? Vertical line test. So this is a function because it passed the vertical line test, but this is not a function because it doesn't pass your vertical line test, right? So that's exactly what I'm trying to say in that example, okay? You're having one ordered pair, which your one as X is assigned to two Y values. Your one as X is assigned to two different values. So this is not well defined. Calculus says it doesn't pass vertical line test. It's the same as what we are trying to say here. You must have one unique output for every single X in domain, okay? Does it make sense? And here another example to just test this too. This is a function that is for X is before 2, for X is less than 2 is defined to be 5, for X is bigger than 3 to be 7. Is this well defined? Does it pass this too? Because
every element in the domain, well, passes one. Has an image of it out. Images unique.
passes one or it doesn't passes one?
It does.
How about if I just looking for F at 2.3? How about if you're looking for 2.5? How about if you're looking for the image in 2.7? Do you have any value for these numbers between 2 to 3?
No, no.
So that's exactly what it says. It says for every element in your domain, you should have one image. But I have several numbers between 2 to 3, which doesn't have any image. Okay, so first one fails. The answer is no. And then number one fails. So this has no image. Can I fix it? Can I fix it to have image for everyone? If you remember in algebra classes, this is called piecewise function, right? This was called in a piecewise function. If you change this definition, has no image. Okay, if you change this function to like X is less than 3, X is bigger than equals 3, whichever definition you want to write, then you don't have any missing points, right? So you don't have any missing points. So this is a function. This pass, this is a well-defined function. Do you know why the pen start to be slow? What should I do? This is not following me. It's really slow.
The battery, did you change it out?
Recently, yeah.
I would probably rub the bottom with like maybe the contact on the inside of the pen is that, you know.
Rub the bottom? What do you
Yeah,
mean?
like when you take the whole pen home, if you're rubbing alcohol, put it on a
Oh, the
Oh.
stylus tip.
yeah, or the style, just like
This one.
Does the surface have interchangeable stylus tips?
Yeah, I changed it recently. I have extra one. I can change it.
Oh.
Do you think this is a problem?
Potentially.
Okay. Thank you. So if I change my example to define like this, is now a well-defined function. So now is a well-defined function. So the problem solved, right? So for the second example that I have over here, it's actually looking for the similar problem or criteria. It says, can we change the domain somehow, the function that is defined like this be a well-defined, or it pass the first rule? How do I change my domain, or which set do I need to put as the domain or the set of inputs that every single element has one image? Does it make sense what the question asked me to do? Which subset do I need to choose to be the domain or set of x's that this function to be well defined? Or for every single x's, you can find one image. Did you understand what's the question? Okay. Basically, this is the same as asking, what is the domain of my function? Do we know from the algebra where this function is defined? Do we know from the algebra where this function is defined? Three x minus 7 has to be bigger than equal 0. 3x bigger than 7, x bigger than 7 divided by 3. So if you set your possible x's or the domain to be like this, and you define your function from this set of x's to all real numbers, so this is going to be well defined. So this is going to be a well-defined function. So one more time, this is exactly the same as what is the domain of the function? Okay, what is the domain of the function? So what would be the A that I have a well-defined function? The actual domain of the function, or possible x's that makes your function to be defined. Is that okay? Makes sense for now? Do we know what's the one-to-one function? Do you remember what's the one-to-one function? One-to-one function says for every single x should be only one unique y's, okay? So you can't have repeated values. You can't have repeated values, okay? So if I go back to the same calculus or algebra example, and repeat the can I have one x1 to be different than x2, but your output or your images is the same? Like saying 2 is different than -2, but image of f of -2 and f of 2 is the same for x squared. So this is not one-to-one. So that is a good example to say this is not one-to-one function. This is not a one-to-one function, okay? So one more time, if I back to the definition, it says corresponding with the different x's, you need to get different images, okay? Corresponding by different x's, you need to get different images. I'm going to go back to the definition. Okay, another name for this is one-to-one or injection. It's one-to-one or injection. So let's write the contrapositive of that. So if you remember, either you can write P then Q is the same as Q naught and then P naught. So contrapositive of that. So I'm just saying, if I say the images of 2 points are the same, you have to end up with the same inputs. If the images are the same, your x's or the inputs must be the same. Okay? Again, if we were in calculus classes and we were working on continuous function, not this discrete math, so then you're saying it passes horizontal line test. So to be a function, you have vertical line test. For being one-to-one, it must pass horizontal line test, okay? But here we are not. We are just trying to prove it by point, which is what we do in discrete math, okay? So like this example, you're supposed to show this is a one-to-one function. So you have to start to set the images to be the same. You see, it doesn't write it. And then so that means you replace x's by x1 in this expression or the rule of your function, and then you replace for x2. A little bit algebra. Can I end up with x1 equals x2? So you have started from this side and you want to end up with this side, right? So it's called direct proof. So I've started with the P, I just want to get the Q. So I can subtract 2 both sides, and then I can divide both sides by a 3, and that's it. So that means you have images the same, you could prove the x's are the same. So this is the one-to-one function. So instead of writing 1 by word, you can just write 1 by number -1. So it's the same thing, okay? Next one. Can I say always line? This is the equation of the line, right? This is the equation of the line. Y equals 3x plus 2 is a line equation. Can I say the lines are always one-to-one? It does pass the horizontal line test. So if you have a line, it has only one intersection with your horizontal lines, right? So yes, the lines are always making your, what we call one-to-one functions, okay? So it's making one-to-one function or injection. So here we are, I have one more line equation. Is it one-to-one? Actually, I know it's a one-to-one. How do I prove it? Is a direct proof. So how do I prove it? Is a direct proof. This is the P and this is the Q. So you just say, if you're setting the images to be the same, there will be like this, and a simple algebra. Subtract 5 from both sides, and then divide by -7 on both sides. So this is exactly what I'm looking for. So then your g of x is a one-to-one function. Okay. Any question here? So how do I disprove it, or how do I say something is not one-to-one? So there should be one example, right? There should be one example that the images are the same, but the numbers are not the same. So I gave you in that top x squared exactly the same example I have over here. X squared is not one-to-one because I have one case that the images are the same, but the numbers are not the same, right? So the inputs are not the same. So actually we have infinite many cases, right? For looking to the domain and codomain, so you can have only rational numbers, right? So you can have only rational numbers to be inputs and your output, but again, there are many examples to disprove that one. You can just say, if I say x1 equals maybe 1, x2 equals -1, so then f of x1 is -1 to the power of, +1 to the power of second, and it's going to be 1 and -1 to the power of second, which is f of x2. So while x1 and x2 are not the same. So you have the images to be the same while they are not the same. You're having images to be the same while they are not the same. So then fails to be one-to-one. Okay. Question here? Does it make sense? So one-to-one is something probably some of us might have seen it, but I think onto, have you ever heard about onto? What do we call onto function? Anyone knows what do we call onto function? So if I go back on top, so like this example, if there was any case that you're having like a D assigned to this 3, so that then it will be onto. So what's the goal this time? To cover entire codomain. So you shouldn't have any excluded number on the right side. So if you're having what we call a codomain, okay, what we call a codomain, it has to be the same as what you call range. So whatever is your codomain covers entirely by your images of your function. So maybe another expression, or maybe the notation that you see for the range in this course is image of f. Range is the set of all images that you can have with the function. So it's called IM image of f. So if you're having codomain all covers by your range, that would be what we call onto. So if I want to write it by quantifier expression, it says for all, being in the codomain, there exists 1x, we're using A in domain such that your f of A equals B. Your f of A equals B, okay? Another expression for that is surjective or onto, surjective or onto. One example, do you think, this is the equation of the parabola. Do you think this is going to be surjective, or does it take all of the R on the Y, right? Do you have every single possible Y's from the real number? Do you have a solution for 3x squared minus 4x plus 5? What do you think? If you're having like a parabola somewhere over here, if you have a parabola somewhere over here, my question is, does the range of my function covers entire real numbers? Whichever point that I choose right over here, below the vertex is not taken by my function. Do you agree with me? So choose one counter example, right? So there exists, so if you just say negation of this quantifier or not to be onto, means there exists something that you can choose from the codomain for all possible A's that you get from the domain. F of A is not the same as B. So you have, there exists like saying -100 in the real numbers, which is your image, I mean codomain. codomain of the f for all of the x's in the real number, your 3x squared minus 4x plus 5 equals negative 100 has no solution. Why it has no solution? Because I learned in algebra classes, right? So if you write this one as a polynomial, and then you make b squared minus 4ac, and that would be 16 minus 4 times 105, 3, it gives you a negative number. So that's why it doesn't have real, that notation in quadratic equation has no solution, no real solution, sorry, because it's negative number, okay? So still a good question is, can I make this function? Can we have some changes that make f to be onto? So can I make this function to be onto? Can I define this function somehow? Can I define this function somehow range to be the same as codomain? Range to be the same as the codomain. So your question is, I want to define one example with the same domain, but a different codomain, which the range and codomain are the same, which this is defined like 3x squared minus 4x plus 5. Exactly the same as asking, what is the range of this function? Question mark supposed to be exactly the same as range of your function. So do I remember from algebra classes how to get the range for parabolas? How do we get the range for parabolas? You have to get the range of the function, so you have to get the vertex. So let me remind you. The vertex is minus b divided by 2a, f of minus b divided by 2a. So here for your function, oh sorry, I mean what was it? Negative 4x plus c, which is 5. That's a, that's b, that's c. So you have a negative 4 divided by 2 times 3, and then f of 2/3 is your vertex. So you have a 3 times 2/3 to the power of second minus 4 times 2/3 plus 5, which you do a little with algebra. I got 11 divided by 3 in the previous class, okay? So then your vertex is standing at 2/3 and 11 divided by 3. So what should I define to be the range? Because as you see, your graph is starting from 2/3, 11 divided by 3. So if you start from the 11 divided by 3 all the way to the infinity, that works, right? Do you agree? In order to make sure whichever element that you have in your codomain gets one image from the domain, or there exists one x that is assigned to that, you have to restrict your y values, your outputs. Your codomain must be the same as your range. So then the question was the same as what's the range of function. So if you define the function like this, then it's onto. Okay? Question here? Basically, I removed this part of this, and then I started from here up there for the range. Any question for this one? Any question for this one? And this is just asking whether this function is either one-to-one onto neither both. So then you're having one first for one-to-one. To try for one-to-one. The other one you have to try for the onto, okay? If you guys remember from the algebra classes, what's the graph of this one? So you know it does pass your horizontal test. If you remember what's the graph of this one, you know it does pass the horizontal test. But if not, you can just try the definition, right? So being one-to-one means starting with the setting the function, the output to be the same, which is 5 plus 1 over x equals 5 plus 1 over x. And then subtract 5 both sides. Oh, sorry, I mean x1 and x2. Subtract 5 both sides, reciprocal both sides. Reciprocal both sides. Yes, that's one-to-one. That's exactly definition of the one-to-one. You have started with the P, you end up with the Q. So this is what we call a one-to-one function. This is a one-to-one function. So is it onto? So means, does it cover entire integers? Do I have any integer which does not have any value? So one more time. There exists one on the right side that for all of the numbers on the left side or the domain, f of a is not the same as b, or 5 plus 1 over a is not the same. Is not the same as b. Do you know any value that doesn't take place? Which value? X0 doesn't work, but y cat could be 0. You can set this one equals 0 and solve it. Another way to ask actually, does this graph have any horizontal asymptotes? Because horizontal asymptotes are exactly the same, the y is undefined. The y is undefined, right? Does this graph have any horizontal asymptote? So I remind you what you've seen in algebra classes. If you have had your original function, oops, your original function of y equals 1 over x, and then when you have it 5 unit shifting up, when you have 5 unit shifting up on this graph, so means now your horizontal asymptote is sitting. What's this number? 5 units up. Yeah, exactly. So then this is going to be exactly the missing point. So is there any b value which there is no output for that? Sorry, which there is no input for that? Yes, that's a 5. So if you set b to be 5, if you set b to be 5, for whichever number you have, whichever number you have for the set of domains or the set of integers, you don't have any value for that. So basically, this is the same as saying 1 over, if you subtract 5 from both sides, is the same as 1 over a never gets to be 0. 1 over a never gets to be 0, so 5 plus 1 over a never gets to be 5. So do I have any value on the y that doesn't take any x's? Yes, that's 5. So onto or not?
No.
Not onto. Make sense? Any question? Actually, we have to remember again, because I said I'm not teaching calculus classes, you're not sitting in calculus class. Calculus classes graphs are always as a solid line. They are continuous function. We're sitting in discrete math, so that means all of these are points, okay? I'm making the graph to visualize, I have to, but remember, these are only z's. So it means you have only point by point. You say f at 1 is 1 point. F at 2 is 1 over 2, so it's another point. If at 3 is 1 over 3 is another point. So it's dot, dot, dot. Your graph here in discrete math is dot, dot, is discrete. It's not just a solid line, okay? Because it's z to z. It's not r to r. It doesn't take all of the values. Make sense? One more example. Is this onto? Is this onto one-to-one neither? Actually, if you want to check something is not onto, so you need to look for the range. If you want to check something is not one-to-one or is one-to-one, you have to keep on in your mind always x squared, because x squared is parabola is very simple problem to think about, does not pass the horizontal line test, or there exists always same images for two right and left, or just symmetrical graph with the negative and positive, okay? So this is really good example. It is, yeah. It's not one-to-one and it's not onto. So one-to-one because of a square. One-to-one because of a square. You have two ways to show. You can start with the P, then end up with the Q, not. So because it's failing to be onto one, so what do I mean? You can say f of x1 is the same as f of x2, or you can use the same letter because it's coming with the integers. It's not a whole parabola, it's really dot n1 and n2. So which means 2n squared plus 3 is the same as 2n2 to the power of second plus 3. Algebra says you can subtract 3 from both sides. You can divide 2 both sides. We don't have any problem with that part of the algebra. We can square root both sides, and that's the problem. So you have started with the images to be the same, but not exactly the same inputs, because it has two possibilities. It could be plus or minus. It could be plus and minus. So this fails. Okay, this is not a one-to-one function. So if you like to bring examples, you don't have to go by the proofs, okay? So you can just say, I know one, like a 1 and negative 1. I know alternative answer for this one is just really bring the example. Say, I know if you set n1 to be negative 1, and sorry, n1 to be 1 and maybe negative 1, 2 or negative 2, 3 or negative 3. And then f of n1 is going to be 2 negative 1 to the power of second plus 3. And then whichever number is right, 5, which is the same as 2 of 1 to the power of second plus 3. And that is f of n2, right? So I have n1 is not the same as n2, but I have the images the same. Either write it in formal proofs and get the different inputs, or you just bring examples. You can write it by examples. For most of the cases, examples are really easier. I have some example that the values are the same, but the inputs are not the same. But again, remember, I'm working on discrete math. They are dots. They are not exact full parabola with the solid line, okay? So you said it's not onto. Can you give me one example that not cover with this parabola? I need one y that on the y-axis doesn't cover with my parabola. We've seen a similar problem, okay? So which go down to the vertex. Whichever number down to the vertex, right, doesn't cover your parabola. So if your minus b divide, yeah, any number, right? So minus b divided by 2a, which is their vertex, on this graph, this parabola is a 0 and a 3. So that means your graph starting from the 3. Okay, so if you choose any number here, so like saying f of n1 or f of n to be 0, then 2n squared plus 3 equals 0, which is below the 3, okay? So then you have n squared equals negative 3 half has no solution. So any number, I tried 0, you can try negative 3. So any number below the 0, below the vertex doesn't give you the answer because it doesn't have any image, okay? Because it doesn't have any value of the n that f of n equals negative 3. So not on 2. Okay. Any question here? Any question here? I have to add one example here and then one more in next class before doing the quiz. So you're having your function starting from z sub 15 to the z sub 15, okay? And then this is defined 4x minus 11, and it's just in mod 15, okay? So two expressions here. Do we know what is z sub 15? Do we know what is z sub 15? What is z sub 15? Set of all remainders when you divide by 15. You've seen this concept in your computer science, right? So it's from 0, 1, 2 all the way to 14. Set of all remainders when divided by. We call it mod, you call it modulus, or you put it the percentage notation. I'm fine with that notation. So but it says your value of your function is the same as 4x minus 11 when you divide it, the remainder when you divide it by 15, right? So you know this concept, right? So let's say whether this is one-to-one for now, onto or one-to-one, we can check both, okay? So for now, I'm checking whether it's one-to-one or not. So I start with the left side. I just decide with the p, f of x1 equals f of x2. So which means 4 of x1 minus 11 equals 4 of x2. Is that writing? So you have the, what was it? F of x1 equals f of x2, but that has to be in mod 50, okay? So then you have 4x1 minus 11, 4x2 minus 11, and that has to be in mod 50. You can add 11 on both sides of the mod, so addition or subtraction, both of them are allowed, so you can do it. But I don't know if you remember or you've seen it, you can't divide both sides by 4 because the way that we divided by 4 was 4 is reciprocal of the 4 is like this. So then you have done in your algebra class is dividing by 4. So in mod 10, the way that we write the numbers, that makes sense. 1/4 is reciprocal as 4, right? So If you divide both sides by 4 or divide by 1/4, first of all, we are working on z is integers, so 1/4 is completely nonsense, right? Z is the set of integers, we don't have 1/4. So what do we have is a 4 inverse. And it has a definition, right? So my concern or my question about this kind of problem is, there exists one A, which is inverse such that 4 inverse times 4 is same as 1 in mod 15. Do I have any number, any integer, exactly from 0 to 14? If I multiply by 4, remainder by 15 is going to be 1. It has to be, so again, division is nonsense for integers, right? So do I know any number in z sub 15, which I multiply by 4, the remainder stays exactly 1. Okay? Yes, we know, right? What's that number? It's 4, because 4 times 4 is the same as 1 in mod 15, or it has the same remainder. So again, do not divide. We are working on z's. So division is nonsense over here. So what is 4 inverse? Basically, based on the mod 15 is going to be 4. So yes, then it works. So then you can just say x1 equals x2 in mod 15. So yes, it is 1 to 1. The good question I had for the previous class is, do I have any case that there exists none A that is multiple inverse? Yes, there exists one case. So that is not 1 to 1. Okay, so for this example, it was a good one. I'm pretty sure you have one example in your homework that this A does not exist. So you can't go from this step to this step. So then, but for this one exists. Okay. So I have to add one more example here in next class, okay? We haven't had enough examples.